What? Okay. So if we all turn our attention to the sideboard real quick, SWPA, students will be able to solve equations for a specific variable and use formulas. Solve equations for a specific variable and use formulas. Looking ahead, this is our last section in chapter 1. On Thursday, we're reviewing chapter 1. Next Tuesday, a week from today, we are going to be taking our first test. Heads up, okay? That will be the deadline for any and all homework from this chapter, okay? Hopefully not too long, okay? No, because we don't have this class on Friday, because Friday is Devil Mania, okay? I'm missing the A over there, okay? Friday is Devil Mania, okay?
By the way,
I know. Good work on that. Yes, all the congrats, okay?
What are you doing?
Okay, Beatrice.
When somebody says hometown, I think of The Bachelor and Bachelorette.
Okay, so on 1.6, equations using formulas. Voices off, attention up here, we're dialed in. Solving for a specific variable. No one, please stop. Some equations have more than one variable. That means they can have 2, 3, 4, 5, 6. You know what? Go on going for it. Like Ricky Bobby, you can be second, third, fourth. Heck, you can even be fifth, okay? So it may be helpful to isolate one of the variables. What does it mean to isolate a variable? What does it mean to isolate something?
Put it by itself.
Get it by itself, okay? So sometimes it's helpful for us to isolate or get a variable by itself. So for example, number 1, 15 equals 2n plus 6p for n. So it says solve each equation for the variable indicated. We have this equation, 15 equals 2n plus 6p. We're trying to get n by itself, okay? You'd be like, Mr. Costa, this seems a lot like algebra. Because it is. But it's something we use a lot in geometry, and so we're building up and getting prepared to use this later in geometry, okay? So the equation 15 equals 2n plus 6p, we're solving for n. Now, don't let this confuse you guys. Do not write this part off the side. Don't write this part off the side. Okay, don't write this part. So if I have 15 equals 2n plus 6, we're going to solve it in the exact same way. We're going to solve it in the exact same way, the same steps. What would be our first step if we were solving for n here? Subtract 6, right? It's adding with n. Right now we're multiplying 2 with n, and we're adding 6 to n. But we subtract the 6 first, right, Marissa? Yeah, totally. Okay, let's put that away, okay? So here, what's going to be our first steps? What would be our first step here? If we subtract 6 here, what are we going to do here? Subtract 6p. Now we're going to subtract 6p, okay? Same kind of first step, okay? I want you to write down this part that I'm doing on the left of. Not the one on the right. I want you to write this part on the left where my pen's at. Okay? We're subtracting 6p from each side. We're going to undo that addition, okay? We have multiplication and addition going on with n, the variable one by itself. I'm going to do that addition, okay? What?
I don't get that you can use a variable with something that doesn't have a variable. Like, how can you subtract 6p from 15? You should be able to, like, do
We'll talk about that. So here, 15 and 6, those are like terms. So we can actually subtract them and get 9 equals 2n and keep going, right? We can do that. Here, are 15 and 6p like terms? No one's saying no, because they're not. Okay? P is a variable, so negative 6p and 15 are not like terms, because 15 has no variable. So we can't actually subtract them and get like 9. No. Instead, we just write it as 15 minus 6p. We literally just write that. Equals. Like we just write that on the left side now. We write 15 minus 6p. Because we don't know what that is yet. We can't specify any more than that. Because they're not like terms. On the right side of the equal sign, we still have 2n we haven't done anything with. And 6p minus itself is 0. Just like the 6 went away, it became 0. This 6p became 0. Since we subtracted 6p, we moved it to the other side. Now, how would we get n by itself on this equation I made up over here? Divide by 2. Divide by 2. And we'd end up getting n to equal 9 over 2, right? So what are we going to do to get n by itself here? Divide by 2. And now we divide the whole left side by 2. Divide the whole left side by 2. We don't just divide the 15 by 2. We don't just divide the 6p by 2. We divide everything on the left side by 2. Now, do we know what 15 minus 6p divided by 2 is off the top of our head? Probably not. Okay, it'd be weird if you did. Okay, so we can just write 15 minus 6p over 2. And then on the right side, what are we left with? Just
And
n. Now, does 2 go into 15?
no.
No. Okay? Does 2 go into 6?
Yes.
It does, okay. Now, if 2 went into both of these, we could do more with it. But right now,
Answer.
we're done. We might look at that and be like, that doesn't look very done. That doesn't look finished. That doesn't look clean. That's because we still have other variables in here. That's just what happens when you have more than one variable. That's just part of what happens when you have more than one variable, which we do. We have n and 2. That's just part of what happens. That's okay. We're okay with that. Our goal was to get n by itself, to solve for the variable. Did we solve for n and n by itself? Yeah. Okay, and we'll see why on the second half of this page why we did that. Okay, we'll see on the second half of this page why we did that. Questions on that first one and how we did that mathematically? Was that any new math? Did I teach you any new math right there? No. We just took old math and we applied it. Took old math and we applied it, okay? Let's look at number 2 here. Okay. K minus 2 over 5 is equal to 11j. What variable are we solving for here? What's it say? Solving for k. Where's the k at right now? The numerator or the denominator? Numerator, the top part of the fraction. So currently we're subtracting k by 2 and dividing it by 5. Now in this case, when it's k minus 2 over 5 is equal to 11j, what's going to be the first thing we're going to do? This 2 or this 5? The 5. Because it's dividing the whole thing. Okay? If it was like this, don't write this part down. If it was like this, k over 5 minus 2 is equal to 11j, you would do the 2 first. But because the whole thing's being divided by 5, you do the 5 first. Here, only the k is divided by 5, so you do the 2. Here, the whole thing's being divided, so you do the 5. You gotta get rid of that division since it's on the whole thing. So we get rid of dividing by 5 by what operation? What undoes division? Multiplication, very good. So we're gonna multiply by 5. Now if I multiply the left side by 5, what do we do to the right side? The same thing, multiply by 5. I'm going to put parentheses and say, hey, that means we're going to multiply. Now, hey, this is a fraction, right? K minus 2 over 5, that's a fraction. Now, oftentimes, it's helpful for us to think of this 5 as a 5 over what number then? 1. That helps us to work with those fractions very often. You don't have to, by any means. But a lot of times we say, hey, it's just easier for us to think about. So we do it. Now, what happens with this 5 and this 5? What happens with this 5 and this 5, though?
Cancel.
No, not cancel. I just say I don't like that. Okay, they eliminate. Okay, they simplify or they divide. Because this 5 and this 5 can cross simplify and they both become what number? 1. Very good.
Multiplying them.
Okay.
5 times 5 is 25.
Okay. But we can cross simplify since one's in the top and one's in the bottom. Okay, so just like if you had, for an extra example, like 5 over 1 times, thank you, Brady, times like 3 over 15.
Yeah.
We can do what we call cross simplifying. So we can say, hey, 5 and 15, 5 goes into both of those. How many times does 5 go into itself? Once. How many times does 5 go into 15? 3. Okay, so 1 times 3 is 3. 1 times 3 is 3. We end up with 3 over 3, which is 1.
So it's not like when a number is like squared or whatever, you don't like normally when you put it outside the parentheses, you do like 5 times 2 is like.
Oh, you distribute.
Yeah, distribute.
Okay. So we could. And what you would end up having is you'd end up having 5k minus 10, but then you'd have to simplify it back down anyway. Because what happens here is we can simplify early or we can like multiply and then simplify later, right?
Okay, so we could do 25.
You could do not 25 because you don't multiply the top and the bottom.
Oh, so this is.
Because this is on the top, 5 over 1, and this is on the bottom.
Okay.
Does that make sense? That's why we're able to simplify this because one's on the top, one's on the bottom.
Do you have an extra set of notes?
If I do, it's in the very back of that blue line. I'm not sure I do though. So we're able to simplify this 5 and this 5 since there's multiplying one from the top and one from the bottom, okay? So on the top, this 1 we would take and we would distribute. So no, this is where we distribute. You take 1 times k and that's k. You take 1 times -2 and that's -2. So we do distribute that 1, we just end up getting the same thing. So that's when you can distribute 2. Okay? Is equal to, what's 11j times 5? 55j. Very good. Now k is not quite by itself. What else do we need to do to get k by itself? Plus 2. K is now equal to 55j plus 2. And we got k by itself, didn't we?
Is that number,
Because they're not like terms. Very good. Yes.
the number before k minus 2, is that 5 over 1? Or what
Yes, yep, it's a 5 rule. Great question, Marissa. Thank you for asking that. Raise your hand if you have questions on this one, or still need this one. Okay. Hey, on number 3 here, what variable are we solving for? W. It has to solve for W, okay? How many W's do we have right now? 2. Now we probably need to get those W's together, right? Okay, so that might be a good first step, okay? You need to get the W's together, then we need to get them by themselves, okay? So I want you guys to try number 3 on your own. I want you guys to try number 3 on your own, okay? And when you're done, or if you have questions, I want you to raise your hand. So number 3, I want you to try it on your own. When you're done or have questions, I want you to raise your hand. Very good. You want to check?
I didn't know what she said.
So far. What do you have to do to get that?
You have to move it.
You're still pretty strong. Whoa!
Very good.
It's cheap. Oh, I spent like $150. And that was just all the cash I had in my wallet.
So I hear this.
I'm gonna start
I
it.
said right before. Now when you get W by itself, what do you have to do with this 5?
What do I do with that?
Divide by
I'm watching.
divide both sides by 5. And make sure we're dividing both sides. Divide both sides by 2.
Sure, that actually.
Make sure we're dividing.
I'll use this. I take it on already.
What? Hey class, we need to get quieter. Everyone's getting a little bit louder. We need to get quiet. Okay?
Did you check mine?
Was that the answer?
We're not gonna be able to do pipeline over.
So I got thinking, good. You wish you felt so. It's too much.
Huh? Well, somebody else can do it.
Yeah.
Yeah, they would zero out there.
And
Look.
is he going? I like going.
Yes, you
Alright.
that.
Attention back up here, please and thank you. Attention back up here, please and thank you. Yes. Varsity won, JV lost. Okay.
Y'all should ask me.
On number 3, 2w minus y is equal to 7w minus 2, and we're solving for w. What would be a good first step here?
Minus 1 equals 5w minus
Okay, so you subtract that 2w from both sides to get all the w's by themselves, so negative y is equal to 5w minus 2. Last two less range out of half plus good.
Thanks.
Is that what you did, Marissa?
Mhm.
Okay. So we have so we subtract 2w from each side to get all of our w's together. We need all of our w's together, okay? Getting all of our like terms on the same side and combining them, okay? So now we need to get w by itself still. So what do we do with this negative 2?
Add.
Add 2. Now do we know what negative y plus 2 is? No, okay, we can't combine them. They're not like terms. So we can write either 2 minus y or negative y plus 2. Either way is perfectly fine, okay? So either 2 minus y or negative y plus 2, I am fine with either. They're both the same thing, okay? I'm going to clarify that again. Negative y plus 2 or 2 minus y, same thing. Now how do we undo this 5 times w?
Divided by 5.
Divided by 5, very good. So we divide the whole left side by 5 as well. Now, do we know what 2 minus y divided by 5 on top of our head is?
No.
Heck, that would be weird if we did. 2 minus y over 5, we just rewrite it how it says it, is equal to what now?
W equals.
Now, if you have it written like I said, there is another way we could write it with the negative y and the 2 switched around. So you could also have negative y plus 2 over 5 equals w. And it's not that one of those is more correct than the other, they're just different, but they're also the equivalent. They're also both equal to each other. Yes, no?
I don't want this to sound like a rude question, but like, why are we learning this?
There it is. Okay, so the reason why we're learning this is because it's very helpful in other content areas, like chemistry and physics, for example, as well as later in geometry in this class, to be able to manipulate equations and to be able to just solve what you were finding, what we're looking for, be able to solve different things. And also, this is complex thinking and problem-solving skills, critical thinking skills, and those are very beneficial in many different branches of life, and math is an area we can practice those in. Can I answer your question?
Like
Yes.
studies on Facebook where they think that like some of the classes school should be eliminated and you guys should teach us actual real life stuff. Like
I agree with a decent amount of that.
yeah.
A decent amount of that I can agree with.
How to do your
Because
taxes.
we don't
Yes.
I agree that how to do taxes is
or
important.
like applying for colleges and all that
Yes,
stuff.
I
Like
think
that's
those
what
are
classes
important
that
skills.
should be eliminated.
Okay, and we're not gonna go down that bunny trail right now, okay? We're gonna focus back on this, okay?
Theory.
Hey, any questions on number 3? Any questions on number 3 here? Okay? Alright. Hey, here's what we're gonna do on number 4. I'm gonna solve it, but I want you guys just to follow along with me. We're gonna solve it up here as a big class, okay? So 3/4 a, 3 over 4 times a minus x equal to k. Okay? So we need to solve for a. What would be a good first step here for solving for a? Move the x. How do we move the x, Skylar?
Adding.
Adding. Okay, subtracting the add x to both sides. So 3/4 A stays 3/4 A. Negative x plus x, that's 0. We don't have to write it. Equal is equal. Do we know what k plus x is? No, it'd be weird if we did, right, Mason? So hey, is it okay if we write k plus x or x plus k? Yeah, it's the same thing. It's called the commutative property of addition. 2 plus 3 or 3 plus 2 is the same thing. Doesn't matter whether you have 2 people sitting at a table and 3 people join you, or if you have 3 people sitting at a table and 2 people join you. Either way, there's 5 people at your table now. Okay? Doesn't matter the order you add, you get the same number. Okay? Now, what is 3/4 doing with A? Multiplying. How do we get to do multiplication? Division. Now, hey, when you divide by a fraction, so if we take any number, let's just say we're doing this 3/4 A, and we divide by 3/4, we divide by that same number. How do we divide by a fraction, Colton? Okay, I just wanted you to stop that, so I just said. Does anyone remember how we divide by fractions? We switch to something else. Reciprocal, what do we do with reciprocal? It's a slang term for it. Reciprocal, because it's like the reciprocal is the flipped version. So people say reciprocal when they remember it. We do something with the reciprocal, okay? What do we change the division to? Change it to a dot, which is what operation? Multiplication, okay? So instead of dividing by a fraction, you multiply by the reciprocal. Okay, so we're going to multiply by the reciprocal, and it's the same thing as dividing by the fraction. So we can multiply both sides by 4/3 by the reciprocal. End up multiplying both sides by 4/3. Please write this down with me. That's what I mean by following along. Thanks for asking. That was probably good for me to clarify.
Why do your grades look like ours?
That's what my class earlier said today. I just don't
Did you take a handwriting class before today or not?
How?
Oh man.
I'm really sorry. I was gonna warn you before I said it.
Oh, man. Like, is your arm sore?
Yeah.
Is your arm sore?
I know.
From doing all that shade. Okay.
It never did.
And never, you're too warmed up to catch me. Okay.
No, I was just asking because it. Ours has a verb.
That's a fancy case.
People write K's like that sometimes.
That's
It
a fancy
happens.
case.
You know what?
Old fashioned.
No, cursive K is.
I mean, you were
Not
just
legal.
saying that math is an important part of life.
That is
It's like
right.
this.
Okay.
It's like.
Yeah,
That looks like an R.
that's a cursive K, right? Yeah. It's somewhere down.
It's literally the same.
This is not an R.
Okay. Whatever. Okay. So this 4 and this 4, they both become what number? 1. This
Cancel
3 and
out.
this 3 both become
Cancel
what?
out.
They don't cancel out.
They do
Brandon.
cancel out.
They simplify out or they divide out. Cancel means they go away. They don't go away. They both
But they
become
can't-
1.
Huh.
You don't even.
Ooh, I'm gonna get triggered. Okay.
Oh.
So we're just left with A. A bunch of 1 times 1 is 1 times 1 is 1. We're left with A. Press up.
They cancel out.
Do I need to take that?
No.
Give it to me. Okay. 4/3 times K plus X. You can write this in one of like 3 or 4 or 5 different ways, and I'm fine with any of them. You can write it just like this, and I'm super okay with that. Okay? Because it's a fraction, I'm super okay with that. Now, if this was just 4 and not 4/3, I want you to distribute. If it's a fraction, I don't care. You can do it like this. You can also write it like this if you want. And put it over 3. You can also write it like this if you want. Don't go away.
If you just have.
You can also write it like this. That'd be cool. Okay? Any of those 3 ways, super okay with. Questions on that? Take open, Lydia. Okay, let's go right below this. Okay. So, using formulas, sometimes solving a formula for a specific variable will help you solve the problem. We'll start to see why we're doing this. We'll apply it a little bit here. What? No way, okay? When using formulas, you may want to use this thing called, we're going to skip that. gonna skip this part for now. Okay, we're gonna skip that little part. Okay, example. We're gonna use some examples of using this policies. I've never heard that noise for a sleep before. Unless rain's coming up, unless I don't even make you feel weird, but like, oh, sorry, it just caught me off guard. Okay, a car's fuel economy. A car's fuel economy, okay, you might hear it called the mileage of a car. Capital E in miles per gallon is given by the formula E is equal to M over G, where M is the number of miles driven and G is the number of gallons of fuel used. I use this to find my mileage all the time. But every time I fill up, I figure out what kind of mileage I'm getting, what kind of fuel economy I'm getting in my car. That way I can figure out, it's a good way to stay updated on like whether my car is having troubles or not, or and try and catch them early. If my fuel economy is going down, I might need to fill my tires up. Oh, there's already a problem going on. Like, how was I driving recently? That kind of stuff helps you figure out a lot of that stuff. Nolan.
It's not about miles per gallon, it's about miles per gallon.
Okay. So, I can't say that's not a good point, but it's not irrelevant. So miles per gallon, that even tells us we're dividing. Miles per gallon means miles divided by gallon, which is what this is, okay? Miles divided by gallon. So we're trying to solve the formula for M. So we're trying to figure out how many miles we drove, okay? So we take the formula, E is equal to M over G. E is equal to M over G, or divided by G. I want you guys individually right now to solve for M. Individually solve for M. That's what letter A asks, solve the formula for M. So go ahead and do that real quick. You do not need to raise your hand. I just need you to solve for M.
Do you have a Prius?
No, not
Do you?
No.
You have a truck, don't you?
No.
Why not?
How about I tell you when we finish this?
Alright, let's bat then.
You probably have the four.
How about I tell you when we finish this?
Alright. We're just on race day, baby.
No, I'm on Thursday.
Kale, what's happening with M right now? It's being divided. How do we undo that division? Multiplication. What are we going to multiply by? G. We're going to multiply by G. If we multiply this side by G, what do we do to the other side, Kale?
The same thing.
Multiply by G. The same thing. Okay? G times E is G times E. You can just write it like that. G equals. Well, hey, this G, we can think of it as a G over what? 1. Okay, now what happens with this G and this G? They
Cancel out.
no. They
I'm
divide
saying that
out.
every single time.
I know.
Don't care.
And we're left with what on the right side?
M.
M. Did we solve for M successfully?
No.
Is M by itself?
Yes.
Then yes, we solved for M.
Wait, I thought you said
Can you tell me right now?
Toyota Corolla.
I drive a Jeep.
Oh, you drive a Jeep.
Oh
It's
yeah,
not
I
a
know
Jeep.
you got it. Oh my god.
Did it stock much?
No, like
Okay.
I've seen you at soccer before.
Sure. If Claudia's car has an average fuel consumption of 30 miles per gallon, if her average fuel consumption is 30 miles per gallon, it's pretty good, and she used 9.5 gallons, how far did she drive? What are we trying to find? M, the miles, right? We're trying to find M, the miles. Hey, is it already convenient that this formula is solved for M now?
Yeah.
Yeah, that's why we did it. It makes it easier for this, okay? Now, 30 miles per gallon. Is that one of these other variables that we have? 30 miles per gallon. Is that either the fuel economy or the gallons? 30 miles per gallon. Is that fuel economy? Yes. So that's our E. 9.5 gallons. Which letter would that be? G, because it says gallons in there. Now, do we have our E, our M, and our G?
Yes.
Can we plug these into the equation to solve for M, miles? How far did she drive? Yeah, we can take the equation G times E equals M, and we can plug these in now and solve for M. Okay? If you're having trouble of knowing, I don't know if this is E, I don't know if this is G, okay? Well, remember up here, our car's fuel economy E, miles per gallon. Well, what label are we given with 30? Miles per gallon. That's a big hint that that's the same thing. Big hint. gallons, 9.5 gallons vacant, that's G. Far distance, miles, okay? So we plug in 9.5 for which letter? G. So instead of G, I'm going to put in 9.5. Instead of E, I'm going to put what letter? 30. Now, what operation are G and E doing in this formula? Multiplication. So what operation are the two numbers going to have to do? Multiplication, the same thing, and we're solving for M. We have 9.5 times 30 is equal to M. That's what it means whenever two numbers are in parentheses like this, they're multiplying, okay? Does anyone happen to have the answer for what M would equal here?
285.
It ends up being 285, okay? 285. Now what's our label for that? 285 what? Miles. So how far did she drive? 285 miles. We want to label it. We want to know that we're not talking about kilometers or feet, or kangaroos or ostriches, or 285 tortilla lengths. Okay, that'd be weird. Okay, we're trying to talk about miles, right, Nolan?
Yeah, but why don't we switch over to kilometers like the rest of the world?
Okay, that would make sense. I agree.
No, it wouldn't.
Good for America, that's why.
Yes. But the imperial system, metric system makes far more sense than the English system that we use. I will say that forever, but we're not going to talk about that now. Okay. Any questions on B about the problem? How we solved it? What we did? Why we did it? Okay. So this helped out because we already had the equation solved for M in our first step, so we're able to answer the equation a lot easier. Okay. We're able to solve a lot easier since we already had it solved. Let's go on to letter B, or number 2. Okay, let's go on to number 2, okay? The formula for the volume of a cylinder. Volume, V is equal to pi r squared times h. Pi r squared times h, where r is the radius of the cylinder and h is the height. This is the formula we're actually going to use second semester in here later on. But we're going to practice just getting a little familiar with it. We're not going to do much with it now. We're just going to practice our familiarity with it a bit. I know. Okay? So, volume V is equal to pi r squared h. We're trying to solve for what variable? Pi is not a variable. H. We're asked to solve the formula for h, okay? The instructions tell us for letter A, solve for h. So we say, what's happening with h? It's being what? Is it being added? No, Jillian, what's happening? It's being multiplied by what? Pi and r squared, okay? So how do we undo multiplication? Divide. These are the questions we ask ourselves. We divide, okay? So what's being multiplied with h? We said it was pi squared and r, or pi and r squared, excuse me. So what are we going to have to divide by? By pi r squared. We divide by whatever we're multiplying by, right, guys? Okay. Now if I divide that on the right side, what am I going to have to do on the left? The same thing. Okay. Do we know what v divided by pi r squared is?
No.
No, that'd be really weird. Okay. So, but we do know now that volume over pi r squared is equal to h. Because pi divided by pi is 1, r squared divided by r squared is 1, and we're left with h. So now we solve that for h.
What does that say?
V over pi r squared is equal to h. We divided both sides by pi r squared is all we did.
I know, I solved that before.
I know. Apparently I need to take a hand.
Yeah.
Oh, you took offense to that. They don't hold the drugs.
It's true. Yeah, you probably won't pass my class now.
Yeah.
That challenge.
You got to make sure.
No, I won't.
Okay, what is the height, letter B, what is the height of a cylindrical swimming pool? A swimming pool in the shape of a cylinder, is what we're going up here, cylinder, that has a radius of 12 feet and a volume of 1,810 cubic feet. Okay, what variables do we know?
12 feet.
Okay, we need to know volume and radius. The radius is what Ian said, the 12 feet, radius of 12 feet, so that's R. Volume, 1,810 cubic feet, what letter is that? D. So we know V and R. And what are we trying to find? What is the height, which is the letter H? Pi is a number. Remember, it's like 3.14159, and it just keeps going forever. So we just call it pi. It's not a variable, though. It doesn't change when we just solve for pi. So we can take all of these, and hey, do we already have an equation set up to solve for h? So we can take this volume is equal to pi r squared h, or excuse me, volume over pi r squared is equal to h, and now we can plug these things in. We can plug these things in. So we said volume was 1,810. So where are we going to put the 1,810 here? On the top. Very good, Ian. Okay, on the bottom we have pi, and then what is being squared? 12 feet. Very good. So we have 12, which we're going to be squaring here. Okay, and that equals our h that we're trying to find. That equals our h that we're trying to find. Okay. Mrs. Hazel, could you do me a favor and start passing out scientific calculators? Hey, if anybody happens to have a scientific calculator, now would be a good time to get one out. If you don't have a scientific calculator, now would be a good time to get one out. And I'm not talking on your phone, I'm talking actually one. Because we're trying to prepare for our quiz, we're trying to prepare for a test. Okay? I'm not talking phones right now. I'm talking actual calculators. Okay? Because you can't use your phone calculator on a test. You can't use your phone calculator on a test. We have to use actual scientific calculators on a test. Okay? So I want you guys to be able to practice it and being able to use it. Okay? Okay? So Mrs. Hazel is passing those out. We're gonna practice using them. But while she's passing those out, I want everyone's attention still up here. Okay? So this is how we set it up. This is how we set it up. Solve for h. Question on the setup. Okay, so our first step is to please excuse my dear Aunt Sally, our order of operation, PEMDAS, would be to do the exponents here with 12 squared. What is 12 squared, or 12 times 12? 144. Okay, a lot of times we'll end up writing that as 144 pi, rather than write the pi after, but it's really okay either way. Now, we probably don't know what that is off the top of our heads. I'm guessing we don't, okay? I'm guessing we probably don't know what that is off the top of our heads, okay? So some of us are going to have to share. I'm going to have to grab a few more scientific calculators for our test, okay? And I'm going to go through a couple different ways to do this. If you have this scientific calculator, most of us do, it's the one with this on the lid, it's this cover, and it's this one. It's the TI-30X. TI-30X, okay? So most of us have that one right now. Those of you who have that, I'm talking to you right now, okay? You turn it on with the bottom left button that says on, okay? Now what I want you to do in order to type this in to solve for h is I want you to type in 1,810. I'm going to type in our numerator. So type that in real quick, 1,810. Then I want you to push the divide button on the far right side. I'm going to push the divide button on the far right side, okay? After you push that, once again, this is only on those TI-30s, the ones I held up, okay? 1,810 divided, that's what this fraction means. I want you to put parentheses. I want you to put the first parentheses, okay? The left parentheses. Then I want you to put 144. And then on the far left side of your calculator, there's a pi button. On the far left side, about halfway up, a little over halfway up, there's a pi button. So 144 pi. You'll need to put a times. If it's written right next to each other, the calculator knows. And then close the parenthesis, and then you can push enter. You can push enter, okay? I don't want flirting, okay? If we were to round to 3 decimal places, round to 3 decimal places. Raise your hand if you want to share that with me. Round to 3 decimal places. Nolan. 4.00. 1. 4.001.
So if you said 4, then it would just be.
If I asked to be rounded to the 3 decimal places, I do this. If I asked just to the nearest whole number, it'd be 4. Does that make sense? Depends on what I ask you rounded to, okay? So those are the TI-30s. Do you have any question on how we find it with that? No. Okay. Those with the other kind of calculator. Raise your hand if that's you so I know who I'm talking to right now. Okay. Sam and Gracie, okay? And me. Okay. So what I need you to do is you would first type in 144 times pi. And you guys don't have a pi button, so you would do 144 times 3.14. So I need you guys to do 144 times 3.14. So once again, if you don't have the calculator, it's like we're going to do 1,810 divided by 144 times 3.14. So I need you guys to do that bottom first, and then we'll put whatever that's equal to down here. So what is 144 times 3.14? 450 what? 0.16?
2.16.
Okay. So it ends up being that. Okay. Then you would type this in your calculator. 1,810 divided by is 452.16. Okay. And then your answer to 3 decimal places is going to be just slightly different than what this one is. 0.003. Are those like insanely close to each other?
No.
Yeah, I think they're insanely close to each other. That's literally 2 thousandths off, okay? Very close to each other. That's just because we approximated pi, but this one does pi out for a lot more digits in the TI-30s, okay? So that's how we use this calculator. Hey, on a test, if you don't know how to use your calculator, ask me or ask Mrs. Haswell. We can help you use your calculator on a test. Very happy to help you use that, okay? Any other calculator questions I will answer after I pass about homework here in a second so we get everyone started, okay? Questions on this right now, on the problem as a whole, okay? And the label here would in fact be feet, by the way. It would in fact be feet, by the way. Okay? I'll explain it. Not right now.
Why did you say bacon so aggressively? Bacon.
Ronnie said we made salsa.
Whatever you do, I don't have.
Ronnie is.
Hold on right now. Here. Let's go ahead and get 50 of them. Double-sided. Hey, real quick, okay? Okay, so, for whatever reason, I don't have enough copies. I had enough. I don't know what I did with them, okay? So we're gonna have to do is I'm gonna have to get, Mrs. Haswell is making some more real quick, okay? Mrs. Haswell is making some more real quick. But I want to go ahead and give out this instruction here real quick on what problems we're doing, okay? On what problems we're doing, so that way everyone knows, anyone who needs to can write this down, okay? So there's two sides of this, there's a front and a back. I want everyone to write this down. There's a front and a back, okay? On the front, I want you to do only the odds. On the back, I want you to do all of them, okay? On the front, only the odds. On the back, I want you to do all of them, okay? Those that don't have a copy right now, I'm sorry. I thought I had enough off. I miscounted. I'm sorry about that. I'll do that in the future, okay? I'll try not to let that happen again. Okay? It's like a stormtrooper. I was off my aiming, I guess, okay? Okay? So, in every move, okay? Those who have your worksheet, go ahead and start working now. Go ahead and start working now, okay? No, but you don't have to use a calculator, okay? But if you can't use your phone right now, that's fine. Okay. Hey, when you're done with your calculator, by the way, at the end of class, whenever you're done with it, go open that bin on my cupboard over there. I'll find where Jillian is. Everyone look where Jillian is. Jillian Wave. Okay, perfect. See that box that says scientific calculators? That's where they would go. Okay? That's where they would go. Okay?
Good job, Donna.
I'm not.
You're Donna. Donna, what are you doing about the weekend?
So this would be, yeah, this is like the second way. We could do this part would be 5. You are special.
Wait, why? Oh my god, wait, I thought you said letters. This might be like.
And then you were able to write that out.
Really?
What?
Oh, fine.
She's scared.
I'm scared.
I said you're scared.
It's just a little bit off what I have.
It's scary.
Oh my god, why?
Good job, Ryan.
Why you backing up? Why you backing up?
-3 plus.
Where is
Are you Quit backing up.
You move.
Let me talk about that. How we do that. Actually, that's good. It's good.
You're not as tall.
I am now.
You're not.
I was then yes I can.
Hey, let's take our seats. Let's take our seats real quick. Class, let's take our seats. Class, let's take our seats. Okay, thank you. Hey, I want to talk about number 1 real quick. Okay, let's talk about number one real quick, guys. That's one of the ones we have to do. Voice it off real quick, okay? We're gonna go through this one together. If we're solving for y, that means we need to get this negative 3y by itself. So we're gonna subtract by 6x. Going to negative 3y is equal to 9 minus 6x, or negative 6x plus 9, okay? We're going to do number one together right now. Thank you so much, Ms. Haswell. Okay? Then we would divide by a negative 3. We would divide by a negative 3 the whole left side and the whole right side. On the left side, we would just be left with y. Now on the right side here, we got to be careful because before, the number we were dividing by did not go into all the other numbers. But does 3 go into 9 and 6? Yeah, so we can do more with both of them. So I want to show you guys what you would do with this. Okay? One second. Yep, I haven't memorized this. Yep. So here, I would say this is 9 divided by negative 3 minus 6x also divided by negative 3. And I would actually go ahead and simplify this out. I would simplify this out because 3 goes into both of them. So, what is 9 divided by negative 3? Negative 3. And then what's 6x divided by negative 3? Minus 2. So negative minus negative 2x. Hey, what happens when you have two negatives in a row?
Turns to a positive.
Positive. So really this ends up being y equals negative 3 plus 2x as our answer. Okay, see how much cleaner this is versus right up here? See how much cleaner this is in our box answer versus up here with the arrow? Okay, that's why we do that. Okay, so when the negative 3, when the number we divide by goes into everything, I want you to actually split and divide everything. When it doesn't, like it did on our notes, then we don't. Questions on that? Okay. Hey, that's a freebie now, right? Number one's a freebie here. Okay? You get this one.
Wow.
Yes, correct.
Hey, you,
I got around.
you said that we got one more.
No,
we
That's been first and last time.
Yeah.
Easy, easy. Because all, there's only one line that
So you can do negative 1 over 2, and negative 2, remember? You can just leave our answer as 1 minus
But I know
negative
it's
2. I'll be okay with that.
Reese's are ugly.
Zora Cheap Liberties.